So this vid's about how to make a WhirliBriggs. One of the most important pieces here is the camshaft. Show you here. Now you're using the old exhaust valve as the new air inlet valve, mainly because it's got that 1/2 inch NPT thread on it there. Makes it easier to put the compressed air in. Anyway, on the camshaft here, you can see I've got double lobes. This lobe here will be for exhausting the air, and this one for the intake compressed air. So on the intake side there, you see it's a very small lobe. Basically, you keep the valve open only about 90 degrees of crankshaft travel, maybe a little bit more, but. And then so to build this, what I did, I basically ground down the original intake lobe, ground the exhaust lobe right off, made the camshaft circular at that point. You can reuse the intake lobe, but you don't need it quite as large as it originally started. Then weld another lobe opposite that one, and then you have to, it looks like they're about 90 degrees offset from the intake lobes there. The original intake lobe. Your new intake lobe is the bottom one. But anyways, as you can see, it looks like they're spaced about 90 degrees apart there. The inlet air and the exhaust air lobes. Anyway, so that's the camshaft, and I'll show you what effect it has here. Now this one here is for a WhirliBriggs that operates backwards. So pistons at the top, starts to go down, it starts to open the old exhaust valve. Inlet, compressed air comes in, pushes the piston down, and then now it's starting to close. You want the piston to, you want the air to stop coming in, and then the piston to continue on down, expanding the air, getting work out of it. Then pistons at the bottom, the old intake valve, now the new exhaust valve starts to open. It's opening up there. Doesn't open as much as before, but that doesn't matter. This is a fairly slow speed engine, and then it's closed when the piston's at the top. They're rocking around a bit there, it's closed. And then this valve starts to open. Opens up, then it starts to close. Then this one again. So that's the way she works. So your inlet air duration on the camshaft is shorter than the exhaust air duration. The other thing I did to improve efficiency was I JB welded up the cylinder head, filled in quite a bit of the combustion chamber. Now what that does, it increases efficiency because you don't have so much dead volume that the compressed air coming in has to fill before you start pushing the piston down. The other thing, you have to make a balance plate to bolt on the end of it. I started with like a horizontal shaft rototiller type engine for this. Much easier than doing it with a lawnmower engine. I don't know what that plate is, 6 inches tall, 7 inches wide, something like that. 1/4 inch thick steel. And the other main component that allowed me to do this is the part that allows the air in. So this is the part of your normal recoil starter here. You can see there it's the same. But I modified it. I welded a 1/4 inch 90 degree pipe nipple on there. And so it mounts on the crankshaft the normal way like that. But then this pipe fitting here is on the center line of the crankshaft. So it spins around in a circle. And it allows the compressed air line to slip. So, and this, I just put this on the end there. That's a counterbalance weight to counteract the copper pipe. Threw it out of balance when I put the copper pipe on, compared with trying to run it on gasoline. Anyway, those are the main components there of the WhirliBriggs. Just to show you.